At an abstract level, racing is just a numbers game. All you're really doing is taking a body of mass, like a race car, and moving it around and over a series of obstacles as many times as possible within a given time limit. Okay, that's all it really boils down to. So you can model that with numbers. Anything can be represented and understood through numbers. And so what I want to do is take some time to give you some ideas that I have about how to analyze your racing performance. Because throughout a given day, you go to, say, a big trophy race, and you go through a few rounds of qualifying, and throughout each round, you might be thinking to yourself, okay, I didn't qualify as well as I would have liked to, so do I need to change my setup? Should I focus instead on my driving? Do I need to do both? What's the problem? So there's a quick and dirty way to do that, and then there's the more detailed analysis you can do later. So I want to show you both. So the quick and dirty way to do it is to just look at the timesheet as it is posted. These are actual race results that I copied from a particular race that I ran in sometime last year. And so what we have here is in this particular race, I finished in second place. I did 24 laps in 5 minutes and 8.12 seconds. Here's the fastest lap, the average laps, top 5, top 10, top 15. Okay. Now, could I have finished in a higher position if I, for example, accounted for any of the deviations in my lap times? And we can ask that same question out of any of these guys. So if we look at, say, Paul or Eric, right? Paul here and Eric, they finished within 6 seconds of each other, okay? So in Eric, let's look at Eric's case. Eric did 23.511, Paul did a 23.505. So it's about a 6 second difference. So theoretically, could Eric have made up 6 seconds just by, say, driving more consistently? Assuming that Paul didn't drive any more consistently than he did. So assuming all else is constant. So if we look at Eric's average lap times, it was a 13.5, but his top 5, top 10, top 15 are all in the low 12s. So what this suggests is that he has some outliers that are pulling up the average lap time outside of the top 15 laps that he did. So that gets into a little bit of statistics, but broadly speaking, if you're going to compare any of your lap times to an average of some sort, don't compare it to the overall average, because if you get marshaled and that caused you, say, 7 seconds, it's going to artificially inflate your average. What you really want to do is look at the median lap time, but the median lap times are not reported in these race reports. They only tell you the averages. So if you want to get something that reasonably represents your median, you could look at maybe your top 10 average lap times. So in that case, Eric's top 10 average was around a 12.3, 12.4, something like that. So let's give him plus or minus half a second, assuming some reasonable distribution there of lap time. So what that would mean is any lap time above, say, 13 seconds, we can call a deviation, or a lap that he could have done better. All right, so if we go through, we have this lap here, we have this one here, that's a big one. We have this one here, and then we have, we can say, we'll give him this one here. Then we have, say, these two here, and then you got this one, and say this one, okay? So now let's set 13 seconds as a cutoff, okay? And we'll just add up the deltas between all of these laps and that 13-second number. So, we can do some basic rounding here. So actually, let's just ignore this one. This would be 23, so that's 10 seconds plus 3 seconds is 13. We'll ignore that one. 13.3, and then another second, 0.2, so that's 14.5 seconds. And then we have another 0.8, so that's 15.3 plus 4 is 19.3 seconds. So assuming he drove more consistently, he could have saved about 19.3 seconds. Okay? So if we subtract the 13-second cutoff, that's 6.3 seconds. So basically he could have done another lap and and cut off an additional 6.3 seconds. So what that would have meant is Eric's, you could say, theoretical time, assuming a more uniform distribution of lap times, instead of being a 23.511, would have been much closer to something like a 24, 11 minus 6, 505. Okay, so that would have actually put him in second place. Theoretically, Eric could have finished in second place rather than third, fourth, fifth place if he had, fewer errors, or basically if he drove more consistently. Okay? And that's a very important point to make here, because his fastest lap time is, it's not among the high-end lap times. It's like a 12.2, and, the really fast guys are in the low 12s, high 11s. His average lap time doesn't look so great, but that's because there are a lot of errors here. So, in terms of his average speed, if you will, he's not particularly fast compared to the people who finished in the top 3. But if he was more consistent, he could have finished on podium. Okay? So, this is something, really simple math that you can do in your head while you're at the racetrack and you're looking at the timesheets as they're being posted to figure out, just at a very first order level, what your theoretical qualifying time or racing finishing position could have been just if you drove more consistently. And this helps you get a first order assessment of whether or not you need to change your setup between qualifying rounds. Maybe you're driving around the track during the race and you're thinking, oh, the car doesn't feel so great, or I see a lot of guys out there who are faster than me, but you also see people making mistakes. So if you say don't change your setup at all and just focus on being more consistent, then you finish in a higher position. Okay? So this is, first order analysis you can do to get a sense of that. Now, up here, for example, between first and second place, right, my friend Sean beat me by over a lap here. He's very fast. Our fastest laps are pretty close to each other. Our average laps are, I'm off by maybe 0.6 seconds here. Our top 5, 10, 15 are not far off. Our top 15 average laps are only separated by about 0.3 seconds, okay? So you could say we're comparably consistent in terms of our lap times, but I'm consistently a little bit slower. So what this means here, the difference between Sean and myself, is that I don't necessarily have to work on being more consistent. What I have to work on is being faster. So how can I gain, say, 0.3 seconds per lap? Okay, maybe I have to change my setup. Maybe I have to figure out a better driving line, around the track. Maybe he uses a different line, I'm not sure. So that's this case here between Sean and myself is quantifiably different than the case between, say, Eric and myself. Okay? So this is what you can do, while you're at the track. What you can do when you get home is a more in-depth analysis here. So if you, just take a picture of your timesheets that are, posted on the track, or maybe you can ask the track owner to send you like an email of the timesheet results, assuming that they save those results into a PDF file or something. Then you can take all those numbers and copy them down into a spreadsheet. Like here, I just literally copied these from a picture into an Excel spreadsheet. And then what you can do is make what's called a cumulative distribution function. It's a CDF. That's the acronym, Cumulative Distribution Function. And all that really means is you take, say, in Sean's case, for example, we take all of these lap times, and then we rank them from, say, fastest to slowest, or slowest to fastest, either way, and then you rate them as a percentile. Okay, so if I flip this over, that's exactly what I did for everybody's lap times here. I'm going to show you how to do this. So, assuming you can sort these from the, say, in this case, the fastest lap time down to the slowest lap time. And then what you do is you just count how many laps that he did. So he did 25 laps. And then in a separate column here, you call it a percentile column. You could either make this the high percentile or low percentile number. So all I did here to compute this percentile, it's 1 minus this particular lap, so we'll call that n, over the total number of laps, 25. Okay? Or if you want to flip this relationship around, you could just ignore the 1 minus and just call it n over 25. Either way, it doesn't matter. And that gets you a percentile for this guy. Now, deeper down the order, we have people like, Paul, Eric, Davis, Butch. They ran fewer laps. So to do the percentile calculation for them, you don't divide n by 25, you divide it by their total number of laps. So say in Butch's case, for example, he did 20 laps. So his percentile calculation here in this particular column would be 1 minus n over 20. And then you get these numbers, okay? And then what you can do is you can plot all of this out with the lap time on the x-axis and the percentile on the y-axis, okay? And that's what I have here. These are the cumulative distributions of each of our lap times, okay, as a function of lap time. And in the next video, I'm going to go in a little bit more detail about how you can make sense of this or how you can interpret this data to be more meaningful to you. Okay, so I'm going to stop here and then I'll do a part 2. Thanks for watching.